Okay, in this video I'm going to do a couple examples of graphing exponential functions by using graph transformations. So I've got videos on graphing basic exponential functions. We'll go through some of that really quickly here as well. And I've also got separate videos on graph transformations, but let's put them together just because I think that people still get a little confused on these. So we're going to do two examples. The first one will graph y equals 3 multiplied by 2 raised to the power of x minus 1 plus 4. And then we've got y equals negative 3 raised to the power of negative x, and then minus 2. All right, so there's a couple different ways that you could really go about, doing these. So, and not to hopefully confuse you, but let me show you a couple different ways that you could think about it. So let's start off with the first one first. And so we're going to start off graphing. We'll start off talking about y equals 3 multiplied by 2 to the x minus 1 power plus 4. Let's again just remind ourselves what a basic exponential function looks like. So here's my x-axis and my y-axis. So let's even just graph y equals 2 raised to the power of x. Let's just graph that one first. So recall an exponential function is of the form y equals a to the x, and the value a is what's known as the base. So in our first example here, we're going to have a base of 2, and our a value has to satisfy a couple requirements. It either has to be numbers between 0 and 1, or our a value has to be bigger than 1. Those are going to be the requirements for our base. And in my other examples, I talk about why that is so. Well, if you graph, you could always start plotting points for y equals 2 to the x. So here's x, here's y. If we've got 2 to the x, well, if we plug in 0, we would have 2 to the 0 power. And be careful here, a lot of people say, oh, 2 to the 0, that's 0. That's not correct. 2 to the 0 power is 1. So we get the power, or the point 0, 1 on the graph. So any number raised to the 0 power, any non-zero number raised to the 0 power is 1. So we know that 0, 1 is going to be on our graph. Well, if we plug in 1, that's going to be 2 to the first, which is just 2. So 1, 2 will be on there. If we plug in 2, well, that would be 2 squared, which is 4. So the point 2, 4 would be on there. If we put in 3, well, we're going to get another power of 2. We would have 2 to the third, which would be 8. So we would have 3, 8. So you can see as our x values get larger, we're going to keep doubling the y value in this case, again, because our base is the number 2. So we're going to keep picking up extra powers of 2. And as we move off to the right, our graph is just going to get larger and larger and larger. So again, a rough graph here. Let's just pretend that this is the point 1, 2, and we'll say up here is 2, 4. Again, not to scale, a rough little graph. So there's 2, 4. Let's go to the left side as well. So if I plug in negative 1, well, let's see, then I would get 2 to the negative first. What is 2 to the negative first? Well, using properties of exponents, I can write that as 1 over 2 to the first. So if I plug in negative 1, I'm going to get out the value 1/2. If I plug in the value negative 2, well, that's going to be 2 to the negative second. And that's the same thing as 1 over 2 squared, which is going to give us 1/4. So I would have the point negative 2, 1/4. Let's do one more just for fun. If I plug in negative 3, that would give me 2 to the negative third power. Well, 2 to the negative third power, that's 1 over 2 to the positive third power. Well, that's 1 over 2 times 2 times 2. That's going to be 1/8. So the point negative 3, 1/8 is also going to be on there. So as we start moving to the left, our y values, okay, so we go from 1/2 to 1/4 to 1/8. Our y values are getting smaller and smaller and smaller. I'm going to twist it here so I can make hopefully a better little graph. Notice though, no matter what, x value I plug in, no matter how far I go off to the left, maybe if I plug in negative 20, well, I would have 2 over negative 20, which is 1 over 2 to the 20th. That's still going to be a positive number, albeit a very small one. So it never as we move to the left, it never dips below the x-axis. It never even touches the x-axis either. We're always going to get some positive number, again, but it's going to get closer and closer to 0. So a lot of times when they ask you to graph these, they'll ask about the asymptote. So in this case, our exponential function has a horizontal asymptote, and our x-axis, recall, we can write that as the line y equals 0. So on the left side, we have this horizontal asymptote. On the right side, well, it's just going to spike off to infinity. So in general, this is what an exponential function looks like if the base is greater than 1. Okay, the y values are definitely going to change, but what I mean is, if the base is greater than 1, as you move to the left, it's going to get closer to 0, and as you move to the right, it's going to spike off to infinity. If our base is between 0 and 1, suppose we have like y equals 1/2 raised to the power of x. Okay, so now our base is between 0 and 1. What happens in that case is our exponential function simply gets flipped. It gets flipped about the y-axis, and you can go through the same argument. You can start plugging in points, play connect the dots, but just to refresh you, it's still going to go through the point 0, 1, but again, now as we move to the left, it's going to get, as we move to the right, it's going to get smaller, and as we move to the left, it's going to get larger. So that's going to be the basic shape of an exponential graph if the base is between 0 and 1. 1/3 x, 1/4 x, 2/7 x. Again, if your number is between 0 and 1, it's going to have that basic shape to it. So that's the first thing that you want to remember about exponential functions. So hopefully that's a quick, good little review for graphing exponential functions. Last word of advice, be careful too. You know, people often get like 2 to the x confused with x squared. You know, x squared looks like a parabola. 2 to the x does not look like that at all. Okay, 2 to the x looks much different. So be careful where your number is and where your variable is. All right, so let's actually graph this bad boy. Okay, so really I'm going to think about this one in a few steps. So we've got 3 multiplied by 2 to the x minus 1 plus 4. I'm going to think about it in a couple steps. The first thing I'm going to think of is, what is the graph of y equals 2 to the x? What does that look like? Well, hey, conveniently, we just graphed that one. The next thing I'm going to do is I'm going to think about, what does this affect? I'm replacing the x with x minus 1. And in terms of graph shifting, what does that do? The next thing I'm going to do is I'm going to now think about, what is the graph of 3 multiplied by 2 to the x minus 1? What does that look like? And last but not least, let's put them all together. Let's think, what would 3 multiplied by 2 to the x minus 1 plus 4, what is that graph going to look like? So that's kind of my thought process. So again, maybe we can do them in a couple steps. Okay, so we just had our graph of 2 to the x, so I'm not going to graph that one again. Right? We just did 2 to the x here. So this is y equals 2 to the x. Recall, if we replace all of the x's, well, in this case, right, there's only a single x. That in this case, it appears as our variable. If we replace the x with an x minus 1, or x plus some number, this has the effect of shifting either, it shifts left or right. And it depends on the sign. Now, and you have to be careful here because you see this -1, and right, the negative direction is to the left. So a lot of people will think, oh, this is going to shift the graph 1 unit to the left. But it's actually opposite. So if I plug in, if I replace the x with x minus 1, it's actually going to shift it to the right 1 unit. And that makes sense, again, if you start plotting points. So, okay, so let's think about it here. So I'm going to take my original graph of 2 to the x, and I'm going to shift it to the right 1 unit. So notice before this was the point 0, 1. That was what was sitting on the y-axis. Well, now if I shift it 1 unit to the right, instead of at 0, 1, well, the y value is not changing. We're just increasing the x value by 1. It's now going to be sitting at 1, 1. And again, if you plug in 1 for x, right, you would have 2 to the 0 power. 2 to the 0 power is equal to 1. So, hey, we do get this value 1, 1. Likewise, this point that was at 1, 2, So originally this point was at 1, 2, which would be up here. Again, now we move it to the right 1 unit. So now it's at 2, 2. The same thing, if I take my point that was at 2, 4, well, if I move that one to the right 1 unit, it's now going to be at 3, 4. And again, we can just play connect the dots. The graph isn't going to look that much different, to be honest, right? Because it still has that same basic shape to it. But that would be our basic graph. Now on the y-axis, this would be the point 0, 1/2. If you plug in 0, you would have 2 raised to the negative first power, and again 2 to the negative first power is equal to 1/2. Okay, so this is now the graph of 2 to the power of x minus 1. Same basic shape. Notice the asymptote hasn't moved at all either. We still have that horizontal asymptote of y equals 0. Okay, so now for my next graph, I'm going to think, okay, 2 to the x minus 1 multiplied by 3. Well, we've got our graph of 2 to the x minus 1. Now we're just multiplying everything by 3. And what that's going to do, when we multiply by 3, that's going to take all the original y values. This will multiply the y values by 3. It's going to multiply all the y values on our previous graph here by a value of 3. And again, if you think about it, that makes sense because whatever we originally plugged in for x, right, you plug in some number, we would get 2 to that number minus 1. We would get some y value, but then we take that y value and, well, we multiply it by 3. So that's going to take all of our original ones. And again, you know, this is not on graph paper, so the scale will be a little bit off, but I'm going to put my x-axis a little bit further down just to give us a little more space. Okay, so if I think about the original y values, again, I'm going to multiply them all by 3. So let's see. This was the point we said on the y-axis, that was the point 0, 1/2. Well, let's see. So here's 1, 2, 3, 4. If I take 1/2 and multiply it by 3, that's going to be 3/2 or 1.5. So there's 1, there's 2. That's going to be the point 0, 3/2. I originally had a point at 1, 1. Well, there's my x-coordinate of 1. But again, now I'm going to multiply the y value by 3. So 1 multiplied by 3 is going to be up here at 3. And already I'm going to be off the graph. So here's 2. If I multiply the y value by 3, I would be way up here at, I'm going to put it up here, that would be 2, 6. So again, when you multiply by 3, what that does is it's going to stretch the graph vertically by a factor of 3. So it's going to be getting larger by a factor of 3. It's still going to eventually approach the x-axis on the left, but again, the y values would just be a little bit larger. Notice again, we haven't moved that asymptote, so we still have our horizontal asymptote of y equals 0. Last but not least, the plus 4, the effect of the plus 4, when you either add or subtract a number on the end, this has the effect of moving the graph. It's going to move the graph either up or down. And this is where it does agree with your intuition. So in this case, I see a plus 4. That's going to move the graph up 4 units in this case. So I'm going to do a real rough sketch here again, and then we'll be done with this one. And then we can go through the other one maybe a little bit faster. Okay, so I'm going to think about the original graph. Let's draw some. So I'm going to put my x-axis way down here at the bottom. Notice everything gets moved up 4 units, including this horizontal asymptote. So this horizontal asymptote was at the line y equals 0. Well, there's y equals 1, 2, 3, 4. That's where my new horizontal asymptote is going to be sitting. So 1, 2, up here at 4. So I know And otherwise, the graph would look exactly the same. If you could imagine taking this graph and just picking it up 4 units, that's what it would look like. So I'm going to make, again, just a rough graph here. And that would be a very rough graph of y equals 3 multiplied by 2 to the x minus 1 plus 4. And if we want to pick out a couple points, let's see. What's a point that we had on there? Let's see. So this was the point, for example, 1, 3. This was on the graph of 3 multiplied by 2 to the x minus 1. Well, again, if I take that y value and add 4 to it, now I'm going to be sitting at the point 1, 7. So there's 4, 5, 6, 7. So we'll say that's the point 1, 7. Our y value was originally at 3 halves, or which is 1.5. 1.5, if I add 4 to that, that's going to be at 5.5. So let's see, there was 4. We'll say, what's the best way? We'll say 5. Let's see, oh, now it's already off because I put that up there. So let's see, 4, 5, 6. Okay, I've totally screwed up the units now. But anyway, so let's just go ahead and make that 0, comma. That would be 5.5. What's 5.5? 11 halves. So that would be a very rough graph of 3 multiplied by 2 to the x minus 1 plus 4. So the moral of the story is the x minus 1 takes the original graph and shifts it to the right 1 unit. The 3 stretches it because it's multiplying all the y values by 3. And then the plus 4 moves it up 4 units. All right, so again, I think these can be a little tricky. Once you do a couple, I guess it's like anything, maybe they get easy. Hopefully they get easier. All right, the next one will be a little bit easier, I think. So let's graph this last one. Y equals negative 3 raised to the negative x minus 2. So again, I'm going to kind of think about this in a few different steps. I'm going to think about what does y equals 3 to the x look like? Well, that's going to look very similar to 2 to the x. Then I'm going to think, what does y equals 3 raised to the negative x look like? Then I'm going to think, what does y equals negative 3 raised to the negative x look like? And then I'm going to think, what does y equals negative 3 raised to the negative x minus 2? What does that look like? So I'm going to be a little bit more sloppy on this one, just to speed it up. You could go through the same argument and plot points, and if you would like to see a more detailed one where I'm plotting points, I'm happy to do that. So 3 to the x still has that basic shape, just like 2 to the x. It gets smaller as you move to the left and larger as you move to the right. The negative x, what effect does that have? Well, if we replace an x, all of our x's with negative x's, this is going to reflect the graph, reflect about the, now this is the question, does it reflect it about the x-axis or the y-axis? And again, you can plot points. It turns out that it's going to reflect it about the y-axis. So if you think about our original graph, you know, it got smaller as you move, it got closer to 0 as you move to the left and larger as you move to the right. Well, it's going to reflect it. It still goes through the point 0, 1. And if you think about properties of exponents, that even makes sense, because we could write, for example, 3 to the negative x. We could write that as 3 raised to the negative first, all raised to the x power, because again, if we multiply negative 1 and x, we'll get negative x. Well, 3 to the negative first, that is 1/3 raised to the x. So 3 to the negative x, algebraically, that's the exact same thing as 1/3 raised to the x. And recall at the beginning we said if the base is between 0 and 1, this is the shape of them. Okay, so on to our next graph now. What does the negative out front do? Well, if you put a negative out front, in this case what it's going to do, now it will reflect about the x-axis. And that makes sense because if you think about 3 to the negative x, no matter what number you plug in for our exponent, we'll have 3 to some number. 3 to any number is always positive. So for 3 to the negative x, the y values should always be positive, which means the graph would always be above the x-axis. But now, since we're putting the negative out front, it's going to take all of those values that originally were positive, and now it's going to make them all negative. So our new graph should definitely be below the x-axis. So now instead of going through 0, 1, it's going to go through 0, -1. So the part that was up here, that was increasing as we move to the left, it's not going to be decreasing as we move to the left. So it'll be getting smaller. And the part that was getting closer to 0 as we move to the right, it's still going to get closer to 0. X-axis, y-axis. So there's a rough sketch, a very rough sketch of -3 minus x. Notice our asymptote, which was sitting at the line y equals 0, it's still sitting at y equals 0. That's still our horizontal asymptote. That one has not moved at all. Well, now we're going to take the graph -3 minus x, which we've done a real rough sketch of here. Well, the -2, this is going to move the graph. That's going to move the graph down 2 units. So I'm going to start off just by graphing the asymptote. I'm going to graph this point that was sitting on the y-axis. And then I'm just going to make, again, a real rough sketch, and we will be finito. So the most exciting stuff ever. Probably not. Okay, so at y equals 0, that was our horizontal asymptote. We're going to move it down 2 units. So now our horizontal asymptote will be at y equals -2. So there's my x-axis and my y-axis. I'm just putting it up there just to give myself, again, a little more space. The point originally in our other graph, it was going through 0, 1, 0, -1. So now if I move it down 2 units, it'll go from -1 to -2 to -3. And again, we said as we move to the left, it decreases. And as we move to the right, it approaches not not y equals 0 anymore, but now it's going to get closer and closer to this horizontal asymptote. The y values are going to get closer and closer to y equals -2. So that would be the graph of y equals -3 raised to the -x minus 2. So, all right, so I hope these 2 examples make a little sense. Again, I've got videos on graphing basic exponential functions and also other examples of graph transformations if you need to see those.